So this is a review session for the very fundamentals of physics, which is chapter 1 and 2. All right. And I'm going to run through the main ideas as usual, like all the review sessions, and tell you the things that you absolutely need to know if you want to answer any questions from the chapter. So chapter 1 concerns ourselves with unit and measurements. Okay. So normally for chapter 1, this kind of thing, unit, prefix, measurement. So this is normally a confirm can score question, but you won't expect much, many questions from this. And normally they will combine this with other topics. Why? Well, because these things are, if you want to do physics, right, you have to have a sensitivity of units. You know, have you seen the meme of physics teacher where you don't give units and they go like 20 what? Orange apples, cows, same idea lah. So unit, prefix, and measurements. So when it comes to all of this, right, normally we'll combine other topics. And because we are also testing this in paper 3, you will expect, generally speaking, I'll write here, maybe 2 to 3 MCQ for paper 1, and maybe 2 to 3 marks, even if it comes out for paper 2, for your P2. So at most, it's 6 marks lah. Again, we are talking about 130 in your entire AS, okay? Because we are testing this a lot in paper 3. That's why there's not many marks, or if it comes out, then it comes out. So the first thing you need to know are basic stuff like what are base SI units? Okay, what are your base SI units and what are the physical quantities? So I want to point out something that oftentimes students overlook because either they rush through the question or they just read very fast lah. It happens. This is a kind of mistake that I can make because I'm also a very fast. I do things very fast, then make some careless mistake left, right, center lor. And if that was you yesterday doing maths, it's okay. It's over now. Focus on your next papers. You can decide later. Okay. So your SI unit consists of this 7, 1, 2, 3, 4, 5, 6, 7. Okay. Do you have to memorize? I'm more like you have to know lah. If you don't know, then basically, have you been studying physics? All right. So I just want to point out one thing. If they ask for base SI units, you provide this list: meter, kg, second. If they ask for base physical quantity or physical, then you talk about length, mass, and time. So if for example, I ask for physical quantity, then your answer is length. If I ask for physical base quantity, length, SI base units, meter. So please read about whether they want physical quantity, then you write all this no. Okay. If they ask for base SI unit, then you write all this no. Okay. So just want to point out. So whenever you write a physical quantity, okay, you also should know how to derive SI units to base SI units. This one is standard, or you go and try some question from the past year collection. The second thing you need to know is to check the equation to see whether it's homogeneous. So when you check equation, right, every term must have the same SI units. Every term must have the same base SI units. I'm going to try a question involving this right now. So the whole purpose of us starting physics with units, right, is just that not only we are measuring something, we also want to know that our equation is correct. So sometimes when you do experiment and you think, oh, I think this, for example, I think that, let's say S is UT plus half AT square. Whenever we derive an equation, we can perform a base unit check where each term will have the same base units. So the base units for S will be meter. The base unit for UT will be meter per second times meter, times second, which is still meter. And the base unit for half AT square, half has no unit. acceleration is meter per second, second square is still meter. So this is what I mean by homogeneous. Homo here means the same, so it has the same base SI units, right? And this is generally what we're looking for. So there is a question that I've asked in my model papers. So if you haven't tried the model papers, you should probably give it a go, especially when you are ready lah. So time your model papers accordingly. So example from the model paper is this one. Okay, this question is a MCQ that I modify into a paper 2 question. Right? It's a so if you're really the type where you are gang spam past year question from 2002 to 2020, dude, you did 18 years of past years. Well done. But wow. But seriously? Okay. So anyway, so this is like an example of checking homogeneity. Okay. So here they will tell you some story lah, some tube lah, whatever lah, doesn't matter. Some story lor. A tube is rolling down the slope in inclined theta. Okay. So what I want to know is actually what does the symbol represent. So this distance here, length, so the unit is m, base SI unit. This base SI unit is second. And then you are given an equation. Okay. A is the internal radius. So I'm just going to circle all of this and put units already. Radius ma, meter lor. We take SI. Suggest suitable units for P and Q. Okay. So what I'll do is I'll open a bracket. Okay. And I will have something like 3L plus A square L over P is equal to QT square sine theta. So I know all three, there are three terms here. 1, 2, and 3, they should have the same base SI units. Okay, so I know the base SI unit for 3L is equal to M. Okay, so let's say this is number 1 now. So number 2, the base SI units for A square L over P should also be M, which also is, so on this side, A square, A is internal diameter, so this is M square. And then this is M over P, and this is M. So if you rearrange this thing, you can cancel the M, and you'll notice that P will be equal to M negative 2. Okay? So you can use homogeneity where every term will have the same, like for example, QT square sine theta will have the base SI unit M. So this Q we want to find, T is secant square. Sine theta is unitless. Sine theta, cos theta, all the angle is unitless. If you really want to ask me why, then think of a triangle. You want to find sine of this triangle, you take this length, I don't know lah, maybe 4 meter, divide by this length, which is 5 meter. 4 meter divided by 5 meter, got unit meh? The unit cancel out ma. Sine, cosine, tangents are ratios. So whether you know this or you don't know, I don't know. You learn enough maths. So this is MS negative 2. So this is what I mean by using homogeneity to check for whether the unit is, whether the equation is valid or not lah. Okay. So other questions from recent past years would look something, hang on, let me go and dig. Okay, something like this may or may not discuss in class, but sometimes they will ask you to find P and Q, and sometimes they will ask you to find it from the index format. This question, so big, too big. This question is from May-June 20 paper 1-1. May-June 20 paper 1-1 question 3. So if you're watching the recording or if you haven't tried the question yet, you can go and find similar questions like this to try. Okay. So frequency F of vibration is supported by a spring. So you're given that the frequency is this one. C is a constant and has no units. What are the values of P and Q? So when doing questions like this, once again, the units for everybody have to be the same. But the good thing here is we only got 2 terms lah. Okay, so if base SI unit for frequency, the frequency is 1 over period, right? So this will be secant negative 1. Okay, And what about this MPKQ? Okay, what is M? M is mass, so this is kg. So bracket here, this will be kg power p. And this is the point in time where people begin to panic. Miss, where got kg here? You come down first, you got k ma. You come down, come down, come down. What is k? K is spring constant. Yo, so mafan one. So let's think, is there any equation that we know about spring constant? So this is the reason why we like to ask questions at this point now. Okay, so K here, normally the most obvious one would be F is equal to KX. So maybe it's time to revisit chapter 1 and sapu and go and collect all these questions that I say, never mind lah, you finish your AS syllabus, you will understand what to do. Okay, because at this point in time, when you sit for AS paper, we expect that you should be able to know all the other equations in the syllabus. Okay, so this F is equal to KX. So K here, if you're looking about base units or base SI units for K, I will take the base SI unit for force, divide by extension. But you see, let's say I think about force times extension and I don't know the base SI unit for force, so I'm going to take MA over X. Break down the equation until you are confident that you know what the base SI unit is. So now we are ready. The base SI unit will be kg for mass. Acceleration is ms negative 2 and the extension is m. And cancel off the m. So this is kg s negative 2. So I'll substitute here kg s negative 2 times q. All right, so there are many ways to do this. Like if you have a faster way, please use your faster way. I'm just going to use the general way, okay? I will combine the index. So right here, kg has the index of p times q, so this will be p plus q. Okay, and the index at the back will be s negative 2q. So I'm going to compare. The first thing I notice is that this s is negative 1, this s is negative 2q. So I can say hence negative 1 must be equal to negative 2q. So from here, q will be equal to half. Okay, yay, MCQ. Okay, so now you got 2 more. What is the second thing that you can compare? You look at this one. Got kg, meh? Miss, no kg, how to compare? You forget my favorite number, meh? Power 0. Because kg power 0 is 1, right? So 0 is equal to p plus q. We have value for q already, right? So q is half. So that way we know p is equal to negative half. All right, so this kind of question is the hardest format that they can ask you. Beyond basic things like, okay, I do show and tell. Beyond basic things like asking you questions, like, so you can go and just scan through your past year collection. For example, this type where they ask you which pair is vector. Okay, what's the base SI unit for Q? Go and try a few of this kind of question. We expect 1. Okay, either the easy one where they ask you to find base SI unit. Okay, so what you need to do is just to substitute the unit for P and the unit for V and A and then do some simplifying. Or which pair is vector and scalar, or what are the base SI units for S, Y, and Z. So go and try question lah. Got so many in the past year collection. Okay, so questions like this, and so many lah. There are quite a few. Okay, so they're all about similar. You do about 3 or 4, it should be good enough. So that's the first type of questions regarding SI units. The second one, so I'm going to call this main idea 1, base SI units. The second type of question is the estimating things. So most students don't like this question because how to estimate all. So normally this one we will expect 1 mark. At most 2 lah, but normally 1 to 2 mark. Estimate the diameter of a pencil the circumference of a human head, the weight of a bottle of water. Last time I used to tell students, You just take a field trip to Tesco or Jaya Grocer or wherever it is you buy your grocery, and then you hold the cabbage, you hold the apple, you feel the weight, stare at things. Okay, so this one you know, you don't know, I don't know how to help you. Because it's just, do you have awareness of what are the sizes of the things around you? The only thing I want to remind you is that whenever you are estimating something, whether it's the speed of the car or the mass of your baby brother, your answer or your estimate must always be 1 SF. Okay, it's just 1 to 2 marks. If you don't know, you don't know. Lor. But sometimes they will link this estimate value with chapter 14, the wave electromagnetic radiation. So they'll ask you, oh, give a reasonable estimate for microwave wavelength. Okay, so when we reach this chapter, I will run through it with you lah. But the electromagnetic radiation spectrum, ranging from radio all the way to gamma. Sometimes. But they could also can ask you to estimate other stuff lah. I don't know lah, diameter of football, temperature of the room, whatever, etc., etc. Infinite, okay, I don't know. Okay, just a reminder, please write your estimate in 1 SF. And try not to make your estimate very funny lah. Like, I think there was once I asked a student to estimate the width of a bedroom, and then the student go and put 7.27 km, and then I'm very stressed. What mansion you stay in? What's the width of your room? 7 km. Living the good life, 7 km room. You go toilet, how? You sit scooter. Take a skateboard. Call a Uber when you want to go toilet. What nonsense. Okay, number 3. Very important. Confirm will ask. You don't know how to do, your physics will take a big hit. Scalar and vectors. Okay. So the first level regarding scalar and vector is scalar is magnitude only. Hopefully everyone here knows this at this point in time. And vector is a bit headache because it have magnitude and direction. If you think about all the physics that you have learned until today, right? Whenever we talk about some new thing with a new chapter, a new physical quantity, I always tell you, okay, this is the unit of this new physical quantity that we're learning, and it's a vector, and it's a scalar. And here is how we treat it, because if it's scalar, we will treat it differently. If it's vector, we'll treat it differently. If it's scalar, the positive, negative sign have different meaning. For example, for energy, positive and negative sign tells you who is doing the work. For vector, positive, negative sign normally has to deal with direction. And in the matter of this direction, if the direction, if it's not parallel, if parallel, no problem, right? If let's say you have a box, okay, let's just shake things up a bit. Okay, we have an inclined plane. Okay, and let's say I have a box, and I don't know, maybe I pull it out with a 4 Newton force, and then there's a friction here, 2 Newton. You see these two things parallel? So I can actually say net force here is 4 minus 2. Means it's not parallel to the ground. I don't care. They just need to be parallel to each other. Okay, so if parallel, you can just plus minus, no problem. But if not parallel, this is where things got problem lah. Problem, so to speak. So if not parallel, right, what we'll do is I normally tell students there are 3 methods, but in physics, there's one that we stick to a lot. So if it's not parallel, option 1, you can draw a scaled vector diagram. I cannot emphasize enough that if the vector diagram is scaled, you should mention what scale you are using. 1 cm to 2 Newton, 1 cm to 5 meter per second, that kind of scale. If you don't mention the scale, then you measure here, measure there also, I don't know what you're measuring. Okay. So the next one would be second option, resolve or resolution of vector. When we resolve a vector, we are forcing the vector to follow the direction that we want. So let's say, for example, obviously this box have weight mg. And this MG very mafan, you know, very problematic. It's not parallel. It's also not perpendicular because if it's 90 degree, we can ignore. So it's at this weird angle, and then now we have to resolve. We have to split into two. Of course, you may be asking me, Miss, why must resolve like that? Because I want to be parallel with everybody else. So this is one option if I want to resolve this vector. But I can resolve this vector so many ways. It doesn't really matter. I can resolve like that. Let's say I change this to here. It doesn't really matter. I can twist the angle. So whenever you resolve a vector, right, please be mindful that we are resolving such that we have two components that are 90 degree to each other. But these two parallel components, okay, let me try and see if I can highlight this using the magic of OneNote. Okay, this component, can I rotate? Ooh, can. But I can only rotate 90 degree. Okay, it doesn't work. But you imagine this thing can rotate. Okay, hang on, let me try. Is it going to happen? No, it's not going to happen. Okay, so when you rotate this one, as long as it's 90 degree, imagine this thing can rotate. Okay, it's not going to happen. So anyway, imagine if it can rotate, right? Then this thing doesn't really have to. We are forcing it to follow the inclined plane, but it doesn't have to. As long as this one is 90 degree. Okay, so when we transfer the angle, let's say this is theta, then this one here will also be theta. So if this is theta, this is theta, when you resolve your vectors, one side, because this is mg, so this will be mg sine theta, and this will be mg cos theta. So whenever there's resolution, what we are doing is we have a vector in whatever direction we want. Let's say now I change to this direction. And we can split it into two components. Oftentimes what you see is we will split into x and y because our brain is used to seeing things either from top to bottom or left to right. So for example, you can split this way. Let's say this is f. So this will be f cos theta. You are beside the angle, so it's cos. If you're opposite the angle, then it's sine. All right, so if you're right beside the angle, cos. If the angle is not beside you, you have to sine, contract, and borrow. So it's sine. No angle here. All right, so physics, confirm you will use this either in paper 1 or paper 2 or both. Okay, this is a very important skill. We use this when we study projectile because we resolve velocity, number 1. X. Combine. We use this when we look at equilibrium. Remember? Oh, in net force 0, resolve here, resolve there. We use this when we use net force is MA on the inclined plane. Especially, where else do we use this? We also use this when we are looking at 2D collision. And we use this a lot whenever we deal with vectors. This happens all the time. So we can ask this as a standalone question in chapter 1, but the skills that you use will transfer all across to chapter 3, 4, 5, the mechanics chapter mainly. Okay, and number 3 is a maths solution, which is we use solution of triangles. But we kind of doesn't really use this a lot. So if you open mark scheme and you know how to use the solution of triangle, which is mainly the cosine rule and the sine rule, I'm not going to talk about this because we don't really use it in physics or in your syllabus. But if you know how to use it, you can use it. Just make sure you show your substitution very clearly so that the examiner can cross-check. Okay, so that would be the entire chapter 1. I'm going to end the chapter 1 by doing a few vector questions. Okay, and we will encounter vector again when we enter the kinematics. Kinematics chapter? Yeah, the mechanics chapters lah. Okay, a few notes about vector is that sometimes, or most of the times, the question that people tend to struggle with are questions that involves drawing. Because you can memorize resolving like a method lah, but drawing is a different case. So like for example, this question from ON19 paper 11 question 3. This one is two vector X and Y drawn to scale. So since most of your studies is online, you know, you tend to use a lot of soft copy, right? Soft copy notes. So when you get your paper 1 hard copy, or even if it's paper 2, and they draw a vector for you, when they say drawn to scale, it means that we are copying the same diagram. And I want X is equal to Y minus Z. So which represents vector Z? So I'm going to move this vector Y when drawing my vector diagram. So this is my vector Y. I copy the vector Y, okay? Can do this on one node lah. Probably can't do this elsewhere. Okay, let me make this thicker so you can see. There you go. So let's say this one you put here. Bloop. So you gotta ask yourself, if I want to have Z, how do I minus Z so I can get to X? Because this X here is my resultant. So to get a resultant vector, I need another vector, probably pointing in this direction, here to here. These. All right. Ooh, what happened? Okay, there we go. So here is your vector negative Z, because this is vector Y. So then X here will be equal to Y plus negative Z, which is Y plus or Y minus Z. And the question is, what is Z? So Z must be opposite of this one, right? So the answer is A, lor. Opposite of this. So the ability to chain together the vector drawing is pretty important. Because if you can't do it, then when they give you vector questions, you may feel a bit stuck, especially when it comes to this and an equilibrium question. So here's another example. Okay. So this one is from Winter 19 paper 13. And you see this arrow is a vector. And this one doesn't represent R as two perpendicular components. So we're going to resolve R. And I can do this on one node, but I suggest for you, okay, let's imagine you don't have one node. You are just a student trying to sit for paper. Okay. So what we'll do is you take your ruler and you build. You got compass better lah, or you have the, the ruler that allows you to build 90-degree. But if you don't, you just take your ruler and you build this way, because we are trying to combine the resultant vector. So I'm using the parallelogram method and say that if I pull forces in both of the direction of these two arrows, the resultant force will be here. This resultant force will be here. This resultant force will be here. And this one will be here. Okay, which one looks the most like R? What do you think? You look at this, you go like GG lor. They all look kind of the same, but not really. Okay, so in this case, right, what we're doing is we have to compare and find the closest one. C is definitely out because C looks slightly downwards. Okay. D also look kind of out because I still need this to point upwards. So this one is out. And the only left or does not represent. Oh, even easier. Then C is out there, does not represent. So all of this, whether it represents or not, it really depends on the angle and how well you draw. I freehand draw like this, it looks very sus, but I think we can say this tree looks the same and this one maybe a bit out. Okay. So there's a question from the chat about why should it be, I don't understand, why should it be downwards? Your Y is in this direction. So in this case, right, what you can do is we just draw a vector diagram. That's all. So we are combining X and Y. So Y plus negative Z is equal to X. Y plus negative Z, because Y is in this direction. Okay. So just bring the vector diagram together. You draw Y already, and then you decide you want to draw X also can. So your X will be in this direction. This is your X. Right? So how do we get from, you start from here. So think about where you start. This is the starting point. How do you end here? This is the end point. You already have this blue arrow, which is y, because x is equal to y minus z. This is telling me that whether I follow the path of x, which is here to here, start to end, it is the same as me following the path of y minus z. So from y, how do I get to the end point? Will be like this, no? Okay? So the only way to get here is this one. There's no other way. How? How do you go from this side to the end point? This is the only way to go. So this will be z, or negative z, because we are doing y plus negative z. Okay, chat? So another question in the chat is x plus minus y is equal to z. Why though? Why would you want to do that? Why? So you're going to draw x this way, or rather x is not your resultant anymore. X is this way, and then you want to minus y, so you will go in this direction. Sure. As long as it's a vector drawing that you can draw, then can already, no? Then this will be your z. So if you want to do this, also can. There are many ways to solve vector diagram. It doesn't matter, as long as you know what you're doing. So this is z. Minus z. Oh, sorry. Negative z. So you find that this is z. Okay? Or negative z. Wait, let me think. X minus y. This is negative z. So if you want to represent z, then it will be in the opposite direction. So it's still A. Up to you lah. However you want to arrange, it doesn't matter. As long as you understand what is going on. I prefer to just stick to whatever that they have because I lazy to move things around. But if you want to move things around, that's also okay. All right. And C and D is totally out, not because of magnitude, but because of direction. Because of direction. If I travel vertically up or vertically down, I will never end up here because the end point is slightly to the left. So I must have some horizontal movement. Okay. C and D is totally out. All right, chat. Any other comments or questions regarding this? No questions? I'm going to move on, Kay. Let me go and dig out a paper tool question to do. Okay, I should do one that involves some form of velocity. Or forces. Or velocity. Actually, this one came out in your trials, right? Drawing the vector diagram. I go and take another one. Okay. We're going to take a question from ON15 paper 22. Also, if you are watching a recording of this, whether you are here live or watching recording, I use timestamp to skip ahead to the part where you can see the question. All right, this one, like that one. So this is not a very common but still can happen question. You know what? We should also do part A because it involves prefix, and I haven't talked about prefix yet. Right. Okay. So let's talk about prefix. In the matter of memorizing or thinking about prefix, right? I have this technique for my brain now because I don't remember prefix one. So 10 to the power of 0 is equal to 1. So this is my baseline. Okay, let's go big. If we go bigger, we will go up in increments of power 3. So you have 10 to the power of 3, 10 to the power of 6, 10 to the power of 9, and 10 to the power of 12. So I tend to think about this like my computer hard drive or my RAM lah. This would be kilobyte. Like a JPEG document is probably a few kilobytes. Okay, this M is mega. Files are normally in megabytes these days, but if you open any files, you can see that this one are all kilobyte, KB. Okay, if the file is bigger, let's say you look at all the videos that I have recorded, this is a bit stressful, but never mind. It can be in gigabyte if the video is long, and if the video is shorter, there's less data. So all of this, wow, all gig one. Okay, so it could be megabyte also lah. But the whole point here is whenever you talk about recording, right, or any kind of stuff, we are, at least I think you or our generation, we should be quite sensitive towards these prefixes because we use a device and we buy devices that has storage. So we run out of storage, we very stressed one. So the symbol will obviously take the first letter. And if let's say I want to buy an external hard drive, it will be in terabytes. Can? So okay. So these are all the R's lah, R. Kilo is a special one, okay? Very special. It has its own little thing. It's a lower lowercase letter, not uppercase. And I'm just thinking that maybe this kilo came from olden days before they standardized everything. Time to go small. Okay, so we do have -2 as an anomalous one. And then we will continue with -3, -6, -9, -12. There's more, but I think this is more than enough for your syllabus. Some people may be asking me, why is there -2 and why is it anomalous? Centi. Because from the human eye, when things are in centimeter, we can perceive it easily because our fingers are about 1 cm width. Ish. Our fingers are about 1 centimeter. About. Estimate the width of a human finger, about 1 cm. So that's why we are used to seeing things in cm scale. That's why we have this special one to cater to our perception of the world. But of course, we are going to go smaller. So this will be milli. And this milli is also a bit anomalous lah. But after that, we are back to regular programming already. So the regular programming would be -6, micro, mu, -9, nano, and -12, pico, p. See all the O? So these are all for the smaller ones. The R's are the bigger ones. The thing that I didn't highlight are the anomalous ones. The anomalous ones probably came around before they have any meeting or discussion to standardize. Like right now, MCO 3.0 already locked down. We still haven't standardized our standard operating procedure, so nobody knows anything. We just wait and see lah. But later on, hopefully with time, people will standardize things. At least the scientists will lah, because we want to make sure that the naming makes sense and is easy for people to use. But whatever that we've been using for a long time, it kind of need to stay, which is this kilo, centi, and milli. So when they ask you prefix-based question, it will look something like this lor. For example, this question from ON15, paper 22, if you cannot see. Question 1. Frequency of X-ray is 4.6 times 10 to the power 20. Calculate the wavelength in picometer. Okay, how to convert? Okay, I use this technique. Again, this one is really up to you. If you have a different way that give you answer, please go ahead. Don't feel like, oh, I must do things the way the teacher does it, as long as your way is not wrong. Okay, so I want to find the wavelength lambda. You want to find the velocity or the speed of light. You can find it in the front page of your exam. So 3 times 10 to the power of 8 divided by frequency. So the frequency is 4.6 times 10 to the power of 20. Okay, for my dear brother and sister who don't know how to press calculator, I walk around, I see people press calculator, I feel so sad. Okay, so whether you are using this format of calculator or you are using the other one, the older one, I don't care lah. Somewhere down here at the bottommost row, you will see this symbol, or you may see an E, the alphabet capital E. Okay, this one. Whoops, crash. Okay, I found this one for free, so crash also I cannot complain. Let me close some stuff first. Ding ding. Oh, got press conference. Life is exciting times. Okay, please use this. You see, I show you again. 3 times 10 to the power 8. So it can look like this. You know what, I'm just going to screenshot and put here so I can draw on it. Okay, so if you know this already, just excuse lah for your brother and sisters who don't know this. So a lot of people actually don't know this. So this thing here is either this or E. So if you press E, this one will look like 3E8. This is if you use the older Casio calculator or the cheaper Casio calculator. Now, if I'm a student, right, I'll buy 2 cheap calculators so that I have spare. But that's me lah. Or you buy one expensive one. I don't make life decisions for you, okay? So this is how you press exponents. Please don't go do this liao lor. If you keep doing this all times 10 to the power of 8, you're not tired, man. You press how many buttons? 1, 2, 3, 4, 5, 6, 7. This one I press 3 only. After a while it adds up, okay? So 3E8 divided by 4.6 10 times 10 to the power 20. Ding. So I get 6.52 times 10 to the power negative 3. 6.52 times 10 to the power of negative 3. Negative 3? Sorry, not negative 3. What talk? Negative 13. Alright, so this is my wavelength, and it's obviously not in picometer because pico is negative 12. So what I would do is I will not touch or not move the decimal point, because whenever I do so, some weird thing will happen. I can adjust prefix better. The same thing, right? Negative 12 times negative 1 is negative 13. Then this negative 12 gets a level up so that it becomes pico. But there's also a negative 1 here. So I need to multiply. So I'm just going to multiply 10 to the negative 1. And this one become pico meter. Okay. Meter, this is meter. So then I can times 10 to the power negative 1. This is 0.652. Sorry, 0.652 picometer, PM. Right? So I would suggest, if you don't know how to move the decimal point, or even worse, if there's a power 2, power 3, you chill first, use prefix to help you. Okay. And the second thing is about SF. So when I copy the data, I did a bit fast lah, but your question paper will always give the speed of light in terms of 2SF. Okay, come I show you. Nah, speed of light. We know 3SF, 3.00 times 10 to the power of 8. So if you think about the perspective of SF, like how many SF to write, this is 3SF. This is 2SF. So this one will be 2 or 3SF. You follow the least SF, which is 2, or you add 1. Least SF or plus 1. The rule of thumb for paper 2 is as long as you write 2 to 3 SF, 99% of the time you are correct. So you don't have to think so much. You only need to think a bit more when you're doing paper 3. Okay, so this is example of prefix question. So like for this one, you are asked to calculate the time for light to travel to Earth in gigasecond because the distance from the Earth to a star is this much. So we know the speed of light is constant, and because the speed is constant, we can use S over T. So 3.00 times 10 to the power of 8 is the distance. 8.5 times 10 to the power of 16 divided by time. We can find time. Dun, dun, dun. 8.5 16 divided by 3 8. Okay, so I get 1 2 3 4 5 6 7 8 2 4 6 8 2.83 times 10 to the power 8. And if I want to change it to 10 to the power 9, okay, this is one way. If you need it, if you can skip this step, go ahead. I can, but if you cannot, you can write like this. And you can always double check. Let's say, for example, 5 more minutes remaining. And then you flip here, flip there, you flip to this question, you go like, GG, did I move the decimal point correctly? If you write out this prefix, you can always double check. Yeah, 8 is 9 minus 1. I'm good. Okay, so this will be 0.283. This 10 to the power 9 is gigasecond. All right, so generally, 3 mark leh. 几时 punya question, this one. Old question, many marks. Okay, so for this one, I think the mark here is when you use V equal to F lambda to find the wavelength. So here is C1 mark. If you arrive at 6.52 times 10 to the power negative 3, negative 13, you get C1 mark. You convert correctly is A1. Okay, I'm not sure whether the C1 mark is the substitution or maybe it's the equation or both. Okay, 2 marks here, same thing. If you take S over T and you arrive at this one is C1, and then if you convert your prefix correctly, it's A1. Okay. So just make sure you write your answer 2 to 3 SF. 2 SF is also okay. All right. So if let's say you have the habit of transferring values from your calculator, I would suggest that you don't do so. Let's say you calculate this one already and you say you say you want to multiply this time by 2 or whatever. Do not take 2833333.3. You just take whatever you have written down. So basically, whenever you write something like this, I expect when I press my calculator, I get this answer. When I press my calculator for T, I'll get this answer. Even if the answer comes from previous place and you paste the answer in, if you have extra decimal point, this answer may run. Then you may lose your mark. Okay? So do not use exact value for physics. Round it to a reasonable significant figure. And if you need to use it for the next part or the subsequent part, use that part. Use the rounded one. 2 to 3 SF. Okay? When you use, so this is a question from the chat. When you use 9.8 is 9.81, is it better to leave your answer in 3 SF? It doesn't matter. 2 to 3 SF. You like lah. It doesn't matter. The substitution matter. So you must substitute 9.81. Must substitute 9.81. Doesn't matter if final answer you write 2 or 3 SF. Okay? Next. But for me, I write 3 lah. For obvious reasons, because I do a lot of maths. I'm a maths person. So I appreciate the extra significant figure. It has a lot of meaning to me. If you do maths, you know your maths teacher will even ask you to write your answer at 0.2833 ... Correct? Yeah. So physics don't write like that, but you at least write. This is the most you can write, okay? You write more than this, you're giving people headache. You write less than this, your heart not feel good. Okay, so this is a middle ground. Okay. All right, the following list contains scalar and vector quantities. Underline all the scalar. Okay, which one direction got meaning and purpose? Okay, acceleration direction obviously got meaning. Force direction obviously got meaning. Mass, power, temperature don't have weight, which is a type of force. You need help with this, I guess go watch video, talk to me, etc. D. This one, I chose this because the vector diagram looks a bit different. You have a boat traveling in a river. Figure, oh, underline the scalar. Good catch, chat. I was waiting for someone to like, miss, are you okay? No, I'm not okay. Anyway, this one. Yay. I think this new person in the chat never joined my classes before. I am a troll. I'm a very troll person. Okay. Now, scalar quantities, the direction doesn't matter. Okay. The vector one, the direction matters. Okay. Good catch. Next, a boat is traveling in a flowing river. And then you give you the velocity vector. Velocity of the boat in still water is this much to the east. Okay, if you, for some unknown reason, don't know where north, south, east, west is. East is Japan. Okay, we are in the east. We are Asian. The Asian is in the west. The Westerners, UK, US, on the west. So think about the world map, okay, to help you give you your bearing. So this is directed to the east. Okay. Then the velocity of the water is this much north of east. So how do we know this is north of east? You look at this direction. If let's say I draw once again this compass, okay, and this one is pointing downwards this way. So if we start from east and it's going to travel 60° north. So here. North of east. A bit weird lah, but sure. So follow the drawing, okay? 60° north of east. Draw an arrow to show the direction of the resultant velocity of the boat. So if the boat go like this, but the water, okay, I'm gonna change color a bit. But the water go down this way. So you take your ruler, you measure the length of this arrow and you go like that here, okay? Hopefully your line is better than my crooked line. So this one is here. This is the water velocity. Let's call this VW. So the boat is traveling towards the east. The water is pushing it downwards and slightly in, I'll say towards the west lah. But if they want to go north of east, then okay lor. So the resultant will be somewhere here. Wow, you please use ruler. I'm gonna write here big. Use a ruler. Do as I say, not as I do, because I cannot use ruler on OneNote. I can, but it will take me 10 minutes. Okay, so if you want to watch me draw this diagram for like a few minutes in the video, then you can, but I don't want to. So this is the resultant. Miss, can I just leave my diagram like this? Can, label. So I will write here big. This is my resultant velocity, VR. Can. Okay, determine the magnitude of the resultant velocity. Okay, I got to bring in the angle first, because whenever I draw a triangle and I never transfer the angle, I'm insecure, you know. And I don't know about you, but I'm actually quite geometrically challenged one. So whenever there's vector diagram, I have to make sure I transfer the angle carefully. Okay, I hope you see how I've transferred the angle. This is the line, this is the horizontal. Between the line and the horizontal with the arrow pointing downward is 60°, and then I do alternate angles. Any comments regarding this? If not, we can now find VR. So there are a few methods finding VR. Okay, so to find the direction of VR, right? This is the resultant because the boat is pushing to the east. My diagram is this one plus this one A plus B is this one. This is my diagram. Okay. So for the chat, I don't understand. Why would you want to point? What other direction can you point? Can you point in other direction? Like this, like this? Oh no, it's pointing downwards. So yeah, early morning brain. Ah, this is what you mean? Yes. A plus B is here. I should drink another cup of coffee. Tick, tick, plus B. Like this? Ah, okay. Thanks. Okay, so we want to find this one. There are a few ways. You can draw a scale diagram. If you draw a scale diagram, I think we've been through this in live class before. You take the ruler and you measure this length of the arrow. Okay, I can't possibly do this on OneNote, so I'm going to write down the method. So this method is step 1. Measure the VB, velocity of boat. Okay, let's say it's 7 cm. Then hence the scale will be 1 cm is to 2 meter per second. Example. I don't know. I can't do it here on OneNote, okay? Right? Step 2. Transfer. If you have not yet, transfer the velocity of the wind. But this velocity of the wind is 8 meter per second, which is 4 cm. So this thing, you make sure you draw the length here to here, 4 cm long. But you also make sure you transfer this one. So not just use a ruler, if can, bring a protractor. Okay. Step 3. Measure VR, the resultant. Let's say you measure already is how many cm. Then you convert to meter per second by multiplying the scale. So this is the diagram method, which is faster. Like less fast is to use either the solution of triangle or resolution. So since I'm not going to use a solution of triangle because not everyone is good in maths or not everyone take maths for A levels, but you do physics, such a brave human being. I don't know how, but look at you, man. So you think about we are trying to add these two vector, VB plus VW, the wind. The wind is like that. Hiya. So this is obviously not in our favorable direction, so we need to split. We'll resolve VW into this. Where's my 60? Where's my 60? My 60 is here, right? Yes, so my 60 is here. Meaning this component will be VW cos 60, and this component is VW sine 60. So I noticed that in the horizontal direction, there is VB that is beautifully flat. I don't have to resolve. And I need to combine VB with this, and they are in the opposite direction. So what I'll do is I will start. Look, I'm doing slowly and step by step. You don't have to show all these steps if you know what to do. You can skip one. You just need to show the key points. So this will be VB, which is 14 meter per second. This wind is 8 meter per second, right? So this will be 14 minus, because this is in the opposite direction, 8 cos 60. So this is 10. Okay, we can repeat again for the y direction. Vy got this one only ma, but it's negative lah. Negative 8 sine 60. 8 times 3 root 2. If you're wondering why I'm slapping my calculator a lot, it's because the battery is dying. Don't worry, I got another one, but it's just, I want to use it until it dies entirely. Living life dangerously. So about 6.93. Okay. So here, this is an example of how I can do this. And then hence, I find the resultant velocity. And I am going to square root this one. 10 square plus 6.93 square. So this is example of not carrying forward all the all the significant figures. Okay, then I will show you a slightly alternative one done by other people, possibly. So this answer is 12.1, 12.2 actually, meter per second. You can leave this as 12 meter per second. Or let's say this student more advanced, okay? They did this. Miss, I no need lah. I can do this in my brain. 8 cos 60 square plus 8 sine 60 square. So if the student do this, then maybe the answer is slightly different, right? Because the 8 sine 60, you expect a lot of decimal point. You are pasting the answer from your calculator. So if I, hang on, 10 square, 8 sine 60. Did I press wrong calculator? Ding ding, let me check. 8. Okay, square, there we go. Ooh, look at this answer. This is 12.16, actually it's the same lah. Okay, but even if they are different, when you round to 2SF, you should get the same answer. That's why CAIE mark scheme tend to be in 2SF. The mark scheme will be in 2SF because we accounted for the fact that different candidates may write differently. Some of the people would like to do step by step. Some of the people would like to just put everything into one and then just write the whole thing. Yeah. You don't need to find the direction. If you have to, then you may need to find maybe this angle, theta. So if you're looking for this angle, then you use solution of triangle also can, but I can always recombine Vx and Vy, right? So if I draw this vector diagram, x is in the positive direction, 10, y is in the negative direction, negative 6.93. And if I want to find the resultant, it'll be somewhere here, don't know where. Somewhere here lah, okay? So if I want to find theta, I can use tangent theta is equal to opposite 6.93 over 10. So I can obviously find theta, and this theta is below the horizontal axis. So below horizontal axis. Let me tangent inverse. Okay. So can they ask? Sure. Means if I draw a vector diagram, then I use protractor to measure. Correct. If you draw a vector diagram, all this no problem. You just use the projector to measure. This is 35 degree. And normally they will give allocation of about plus minus 2 degree lah, or 10%. Okay. All right. So try not to write answers in square root here, square root there for physics. Okay. Because we want something in the number format to check for significant figures. Okay. And another question in the chat. If I get 12.5, how do you get 12.5? How? What is your working? You will never get 12.5. What is your technique? Unless you draw vector diagram, then maybe your drawing is not perfect. There's always some form of leniency here. But if you use calculation, I honestly can't see how you get 12.5. Show me your working if you are in the chat. Let me know. But otherwise, you round to 2SF will be the same law. Doesn't mean if let's say for example, you press wrongly or something is wrong here, and then you happen to get 12 that you get at the answer, okay? So the mark here lies in the fact that number one, you resolve correctly. I see the correct resolution at the correct direction. That means the cos 60, the 8 cos 60 is together with 14. And the sine 60 is alone. Then you get 1 mark. And then when you use the resultant, and then you get this one is 1 mark. So if let's say you resolve wrongly and somehow don't know how you get the right answer, the answer is 0. Because what are you doing? You just happen to get the right answer, but your technique is wrong. We focus more on the technique. Okay, so like for this one, this you cannot round to 7. Why would you round to 7? You are in between working. You're in between working, so you will not round this to 7 yet. All the rounding should happen at the end. When you are like, okay, I'm going to copy my answer on the dotted line. You're gonna sign it. You're gonna sign the answer on the dotted line. Then only you round to 2SF. Okay, all this intermediate value you want to add SF can. Don't want to add SF, so never mind. You want to put this whole 8 sine 60 inside also can. Like for this one, I see A. This one correct. This one correct. C1. Then you square root and get this one. Then A1. Done. So do this if you want things to be separate and clear for yourself. But at least write this. This is the shortest format that you can write. And only use this if you are good. Okay? Please, when your working is 100.2852 and you use 100 to carry forward, I don't understand where do you get 100.2852? But I don't understand. DM me. I don't understand how you will get 100.2852 here. How is it even possible? What are you doing? Cos 60 is half. Okay? So if you don't want any of this transfer headache, then you do like that. Then you won't be transferring. But generally speaking, just round to 3SF and move everything. End of story. Okay? So let's not spend any more time here. We can move on, please. Shall we? Transfer 2SF is good enough. 2 to 3SF. So if it's intermediate, 3SF, like at least 2, but 3 is okay. So transfer. You want to transfer more also, never mind. Okay? It doesn't matter. Refer to the mark scheme when in doubt, because they will show you what they substitute. Okay, so that's the end of chapter 1. I'm going to quickly move into chapter 2 before I just give you brief commentary about paper 3. All right. So chapter 2 is about measurement technique. Okay, so when it comes to measurement, a lot of it we will test in your P3. So things that you should know how to use to measure, which I will not cover in this video because you can watch a video about this, is micrometer. And you need to go and study anyway, right? Especially if your paper 3 is coming. So micrometer, screw gauge, vernier caliper. So these are things that you probably need to look at if, let's say, you don't know or you forgotten how to read them. Okay, for quick hands-on notes, okay, if let's say you want to go and find, like for example, you're standing outside the exam hall, you can go to the ET Physics channel. Okay, so we will provide, there's a lot of things about what is accuracy and precision. You can click through and look lah. Okay, so this one is things that you want to just look through before the paper if you need it. Okay, especially when it comes to rounding and SF. Right? The second thing is about in your class notes. Okay, I have inside the lab practical channel, I have this P3 lab skill guide, and there's a how to use. I'm sure this is in your OneNote somewhere, but in case you don't know where to find it or you want a place to go and find all of it, this is here lah. Miss Ellie has taken a beautiful photo of your vernier caliper and how to use it. Okay, so go review it yourself, watch the video, don't understand, disturb me. Okay. The second thing about question 2 is calibration. Okay, so calibration question tend to come out in your MCQ. And this calibration question, normally you will get one question only lah. The calibration curve. I will do one right now with you. So let me go and find calibration skills. Dun, dun, dun. Dun, dun. Okay, so I will show and tell because you have these notes already somewhere. Okay, calibration questions are questions that are like this. You scroll through your past year question, you see something like this, you do lor. Scroll through your past year question, you see something like this, you do lor. I will do one or two later lah. So these are all calibration questions. You will expect to get maybe one in your objective. Just one. Okay, so when it comes to this kind of calibration question, I'm going to try to do something a bit more recent. Let's see if I can find one that is more recent. From your 20. So calibration rarely comes out on its own in paper 2 because we will ask a lot of this in paper in A2 lah. So that one is like we can wait and ask more later. So if they ask, it will just be one lah. If they ask. Okay, so in winter 20, there's only one question. So I'll do that. But it's probably also, I probably discussed this in class before. Probably. Most of the questions. So this is winter 20, paper 1-3, question 4, or ON20. So calibration curve is shown for an ammeter whose scale is inaccurate. Look at this. Hiya. You're supposed to measure 1 ampere. You measure your reading is 1 ampere. Okay. You're supposed to measure 2 ampere, but your reading is 0.18. Supposed to measure 3 ampere, but your reading is 0.28. Sadness. Supposed to measure 0.5 ampere, but now your reading is 0.6. What? Okay, so 2 readings are taken on the meter at different times during the experiment, 0.13 and 0.47. Okay. So the readings is 0.13 and 0.47. So I'm going to rub all of this. I'm just going to show you how the curve is not so good. But 0.13 to 0.47. So we're going to go back to the curve and see reading from the meter. So it's reading from the meter. 0.13. Miss, where is 0.13? Half a box. Okay, here is where I want to nag you. Half a box can read, can plot in theory paper, cannot read, cannot plot in practical paper. Am I clear? This is 0.13. You can say, Miss, you hypocrite. You say cannot do half a box. Yes, you cannot do. You cannot, but they can. Theory paper can read half a box. Practical paper cannot. I don't make the rules. Okay. If I want to guess, I'm just going to guess that it's because the theory paper is not you doing the experiment. So they have better precision. Okay, they are flexing. Okay, so anyway, we go from 0.13 to 0.47. Ding. That's why you confuse lah, because they are not because it's not consistent. And I feel I'm just guessing that's why lah. Because theory is they are just theoretical, you have better precision, I guess, but it's just theory. Anyway, let's continue. So when you read 0.13, the actual reading is not 0.13, it's 0.14. And then when you read 0.47, the actual reading is not 0.47, it's 0.44. So hence, the actual change in current is actually 0.44 minus 0.14, which is 0.30 milliampere. Note that I continue the decimal point, or SF. Okay, so this is an example of calibration curve. Do we have other questions of calibration curves that are a bit more confusing? I think generally no. And most of it I already discussed, but I'm going to discuss one last one. There's nothing to do about reading, but more to do about trend. So this is a repeated past year question from May, June 18, paper 1-1. The good news here is there is a tendency for certain question to repeat. Most of the time, up to 20% of the paper is repeated past year question. Question 1, paper 1, sorry. So if paper 1, 20% to 25% is repeated past year question, it is in your best benefit to go and do past year questions. So, like that all. And even if you don't know why the answer is, let's say the answer is A, you don't know why the answer is A, but you know the answer is A, A lah. Unless you want to come and ask me, okay? So that is to your benefit too, especially MCQ, but not paper 2. Paper 2 is not that common to repeat in its entirety. So MCQ we expect about 20%. Unless CAIE watches this video and change his question, then I cannot do anything. Okay, so in this circuit, you have a meter. We're going to use it as a thermometer. So the ammeter is connected in series with a thermistor. You know what? Now, after all the circuits you have studied, right? A thermistor is basically some resistance that will change with temperature. When temperature increase, resistance decrease. There. Why? Because more charge carrier, more excited electron to carry the charge. Which diagram could represent the temperature scale on the ammeter? Okay, so even if you don't know that, just look at the change in R. When the value of temperature is small, when T is small, look at the R. Wow, drop so much. And then you look at the temperature of T when it's hot here. Look at R, drop so little. So at this point, when T is small, change in R is large. So we expect a lot of deflection. So the deflection is more. So which one shows more deflection at lower temperature? Not this one, because I think I've zoomed in enough already, but I'll zoom in some more in case you can't see. If you look at this one, oh yo, so close cannot. With this one, so close cannot. So this 2 is out. Okay, now you're left with this. If you understand how a meter works, right, the zero reading is here one. Where got meter zero reading here? So the answer is A lah, okay. And then here, if you just want to complete T large, when T is very big, the delta R is small. So because of this, the deflection is less. Okay, so they could ask this kind of calibration question, very seldom come out in paper 2. Miss, what comes out in paper 2? Well, funny you ask. Paper 2 tend to come up question where you have to calculate a bunch of uncertainty. Okay. And that's it for chapter 2. But let me go and dig out a question to do. I don't know which one I haven't do. I don't know which one I have done. So I guess it doesn't matter. Okay, it doesn't matter. Every time I say it doesn't matter, I think of The Rock. You know the meme where it goes like, it doesn't matter. All right. So let's talk about uncertainty, which can translate to your paper 3, but paper 3 is not as stressed. So maybe I separate out lah. Paper 2, uncertainty. Number 1, we look at identities. Okay. Wait, not before. Before we talk about identities, we should talk about convention. How to write uncertainty. Okay. The first uncertainty convention is, let's say I measure the length of my, I don't know lah, what am I measuring? The length of my pencil. So length of a pencil, maybe I use a meter rule, 10.2 plus minus 0.2. Let's say I put plus minus 0.2 cm. Miss, absolute uncertainty is how to write? Because this one is written as L plus minus, so I'm going to write down here. Always when I write the side, people cannot see. Okay, this one here, this is L is equal to, this is the reading, plus minus del L. Okay, so some considerations. What is this? Okay, for those of you who do chemistry, listen to me carefully. Before you start the paper, look at the front page. Oh, physics paper. So all the chemistry convention, take out from your brain, put nicely, put one side, and install in your brain when you sit for chemistry. Okay, chemistry and physics is not the same. Do not get confused. If you don't know whether you're in a physics lab or a chemistry lab, if you don't know whether you're sitting for a physics paper or a chemistry paper, I don't know how to help you, okay? You should know what paper you're sitting for. For physics and chemistry, it's very different. I can explain to the cow comes home, which I keep explaining. For chemistry, right, when you measure something, you measure it with high accuracy because what do you measure in chemistry? You measure things like volume of acid, volume of base, mass of this powder or that white powder, not MSG, but other powder. So you measure all these things. You use a digital balance, which is very accurate, correct? It's digital balance. How else can it not be accurate? It's very precise, accurate and precise. If you measure using a measuring cylinder, as it is your measuring cylinder, do you set the 0 point? Do you adjust for zero error? No, means I pour only, correct law, you pour only. So you never decide where 0 is, you just and you pour. Then you put your eye here and you read the scale. So there's only one time where you use your eye to read the scale in the measuring cylinder, which is when you read the final reading. You do not read the initial reading. That's why the absolute uncertainty when you measure volume is plus minus half the smallest division, because you only read one time. But for physics, if let's say I'm measuring my pencil, let's say I measure a pencil like this is my pencil, and then got eraser at the back one. And then I want to put my ruler here. Hiya, so 麻烦 one. I put the ruler here. I got to like adjust my eraser so that this one is 0. My eraser is not very uniform. I erase here, erase there. Maybe I get some weird shape happening here. So I'm just like, roughly. Or in Malaysia, we say agak. So you already agak here. This is already half a small scale, smallest division. And then you're going to measure to the tip of the pencil. Second problem happened now. Where is the tip of the pencil? Is it a uniform cone? No lah. Who sharpen pencil so perfect one? Where got? You just don't know. You just roughly lah. You put your eye here and then you again roughly. So if you roughly here 10.2, it doesn't mean it's exactly 10.2 leh, because of the shape of the pencil. So here you already have another half, the smallest division. If you take reading perfectly, you already has half and half. But this is not perfect because why? Pencil is very small. Your eye cannot actually see where the sharp point is. And this eraser will block you from seeing the 0 reading. Or you actually need to extrapolate and you don't have this set square thing you can put here and you don't have the set square thing that you can put here. That's why I increased to 0.2. So for physics, especially in paper 3, right, when it comes to estimating absolute uncertainty, it is always bigger than the smallest reading. The very minimum perfect is already smallest reading. So there's no such thing as half the smallest reading. Okay? There is no such thing as half the smallest reading for physics. If you go to the folder where I share the notes with you in your P3 channel, you see it, you see. Because we understand students are very stressed one, so we actually have a comparison across biochemistry and physics. I will run through this later, but you can use this as a reference. So this absolute uncertainty has to be more than half the smallest scale. Okay, so a few things. It will be at least the smallest reading. It tells you about the precision. Doesn't tell you anything about the accuracy. For all you know, this ruler Ch1 one maybe start from 10. Don't know. Or maybe there's a problem with the ruler. I don't know. Okay, it only tells you the precision. It has to be in 1 SF, and it is very dependent on the method of your experiment. This is not the case in chemistry. Okay, chemistry experiment is very different. You go back and think lah. Chemistry experiment, what does my chemistry teacher emphasize? Physics experiment, what does my physics teacher emphasize? How you write your answer. I don't care whether it's accurate or not. If CAIE asks you to measure the length of a pencil, they will give you mark as long as the length of your pencil is between 10 to 15 cm. Let's say the exact pencil is 10.2 cm. I will give you mark anywhere from 8 to 13 cm. Large range. What do we care about? You must write the unit. You must write to the precision of your measuring instrument. So precision here, we look at the decimal point. Decimal point must follow instrument. What kind of instrument do you use? I should be able to tell immediately upon reading. So this decimal point will also, that's why this decimal point will follow the decimal point of delta L. So the decimal point of L follow the decimal point of delta L because of precision. Precision of L will follow delta L. Does that make sense? You are using the ruler, ma. It will be very weird if you can read more than one decimal point in the perspective of a ruler. So hopefully you understand it's not just rules that we want you to blindly follow. It's more like there's a reason why we're writing like this, to honor the ruler that you are using. The question from the chat. The perfect condition uncertainty of a measurement is the smallest division. Divide by 2. If you measure an object for physics, if you have to measure 0, okay? If you have to measure 0, that you have to set your 0. And in physics, we always have to set our 0. Okay, let's move on to part 2. Besides the convention, we are going to talk about percentage. So for percentage uncertainty, we will take del L over L times 100%. This answer I much prefer in 2SF. Once again, when you estimate, this one will follow the precision of instrument. Whatever instrument you use lah, and make sure you times 2 to times 5, because in paper 3, this one is rarely accurate. Because they want you to write limitation and improvement. If they give you a perfect, almost perfect measurement, then how? You got nothing to write, lor. Okay, and finally, identities. So there are only a few identities you need to know for your AS, namely the first one. If A is equal to B plus C, then the uncertainty in A will be equal to the uncertainty in B plus the uncertainty in C. So for example, if you measure the perimeter of your book, you measure the width, you measure the length and the width, and then you add the perimeter, so you are adding the uncertainty. Okay, even if you minus, this one is still plus. So uncertainty can only increase and it will never decrease one. The more things you measure, the more uncertain you are. Okay, so if you look at the COVID data, they call this confidence interval. Same idea. Okay, next, if A is equal to B to the power of N, this will be B times B times B N times, right? So the uncertainty in A will be N uncertainty in B. But whenever we have an equation like this, right, the units left and right is not the same one. Right? Like for example, area is meter is, I don't know, x square. Nah, xx. The unit is not the same. So what we gotta do for these two, because this unit is meter square, but this unit is meter. Not the same now. So we have to divide this one by A, divide this one by B. AKA, we will use percentage uncertainty. There. We use percentage uncertainty. Identity number 3. If A is equal to BC divided by D. Oh. So then the uncertainty in A over A is uncertainty in B over B plus uncertainty in C over C plus uncertainty in D over D. So basically what we are doing is we sum for these two identities. We take sum of percentage uncertainty. Okay. If they ask you in question 2, I mean, if they ask you in paper 2, they can ask you a question like this. So generally in P2, you will expect about 4 to 5 marks involving this kind of calculation. If P1, 1 MCQ. Hey, hey. All right, let's do a question. And then we'll close chapter 2. Dun, dun. I think I opened too many PDF. I'm confusion. Okay. All right, so I'm gonna choose a question that I think I haven't discussed, but I'm not sure. This is from March 16, paper 2-2. So they can give you any equation, even the equation that is not in your syllabus. It doesn't matter, just use it. And if I'm student and I see this, I'm very happy one, because it's confirmed full mark question. There are no tricks here if I don't make a careless mistake. So if I mind my decimal point and my significant figures, things should be all right. Okay, so I'm just cropping the question. Okay, so here, the speed of a transverse wave in a uniform string is given by this. Speed in a uniform string, this one is chapter 15, superposition, stationary wave. Okay, so the velocity depends on the tension one. But anyway, experiment is performed to determine the speed of the wave. Measurement is shown here. Okay, they give me percentage uncertainty. I happy because this is del T over T, this is del L over L, this is del M over M. I'm a happy kid. Let's work. State an appropriate instrument to measure the length L. If something is 126 cm, which is more than the meter rule, you don't write like meter rule. You can use a measuring tape. Nah, the one you can pull out, and then if you are not careful, it will snap back in and slap you in the face one. You know, that kind of Phua Chu Kang measuring tape, the construction tape. Okay, can. Anyway, use the data to calculate the speed V. Ui, bonus, this one. They give equation, they give number nicely in the table. If you don't get mark, what happened? TL over M. Okay, let me think. What are the possibilities that we wake up late for exam, we rush, and then we make a careless mistake? Units. Okay, so in the perspective of units, this is meter per second. So this one have to change. This one also have to change. Okay, why? Because this is Newton. So think about SI unit like formal wear. If you go to an event and people already in SI unit, the rest also must be SI unit. Okay, so this one is 1.8. Length I convert to meter, 1.26, and 5.1 convert to kg times 10 to the power of -3. Right, so this is what I mean by please make sure you convert to SI. If you don't do this, then you just say bye-bye to your marks lor. Don't do this to yourself, please. If they give you this nice bonus, it is nice. It is great. Okay, so if you press your calculator, this will be 21.1. You want to write 21 also can. Okay. And mark scheme also allow meter rule. I guess also can . You just measure halfway, make a mark, then you measure some more. Okay, can. Next, using your answer, determine the value of V, done already, with this absolute uncertainty. Okay, so basically I need del V. Okay, I'm going to copy the equation over. V is equal to square root of what? TL over M. TL over M. So uncertainty in V, percentage uncertainty of V is equal to, you see this square root is power half, right? So I'm going to change this to power half because it's square root. Okay, so this will be uncertainty in T over T plus uncertainty in L over L plus uncertainty in M over M. Okay, time to go and harvest the values from the table. Del T over T, 5%, 1%, 2%. 5%, 1%, 2%. This is 8. 8 times 2 is half, 4%. So the percentage uncertainty for V is 4%. So hence, del V will be 4% multiplied by 21.1. If you're feeling a bit paranoid, then you write 0.04 times 21.1. This will be 0.84, but it should be written as 0.8 because 2 SF. No, wait, sorry. What 2? 1 SF. 0.8. So that means the precision here is 1 dp. So the precision here must also be 1 dp. Look at the 21.1. We have to take everything. So it's 21.1 plus minus 0.8 for an easy 5 marks. Okay. Can you see this one? It's just like, thank you, CAIE, for blessing me with this question. Okay, other problems regarding the question would be, let's say this one, pretty sure I discussed this in class before. If not, go and try. You see, this one, they give you absolute uncertainty, but they didn't give you the percentage uncertainty. So you need to find the percentage, which would be pretty straightforward. It takes 0.5 divided by 9.6, 0.01 divided by 2, and 0.1 divided by 22.1. Okay. And if let's say certain equations they won't give lah. For example, a volume of a cylinder. If you don't know how to find the volume of a cylinder or a sphere or those general shapes, then rip lor. I'll press F for you. Just okay, pi r square, all that. We expect you to know lah. Pre-U liao, you're at the doorstep of university. Come on, you can what? Just tell yourself, I gotta know this. All right. So if it's like some complicated equation like this, they'll give you. If it's about calculating density, surface area, all that, especially for common shapes like sphere or cylinder or rectangle or cuboid, that one you should know lah, okay? All right, so that's kind of it. Am I missing anything from chapter 2? Oh yes, one last thing, the precision. Okay, I will just roughly mention. The precision, accuracy, what else? Precision, accuracy, and error. Systematic and systematic error. And what else? What's the other one? Random. Okay. So precision and accuracy, I've said many times already. But the whole idea is, ideally, a measurement should be both precise and accurate. Okay. But precision here is to degree to which the measurement is repeatable. So the one that you need to know is that the precision is the smallest reading, smallest division. Okay, size of the smallest division. That is precision, which has to do with decimal point. Okay, so like if you think about this in the perspective of precision, that means if I can measure to 4% accuracy, sorry, 4% precision, and I have to write this in 1 SF, so this is my precision, 1 decimal point. Okay, when it comes to accuracy is how close the value is to true value. So it's a confidence. It depends on how confident you are when you do the measuring. By skillful experimenter. Okay, and accuracy is expressed by the absolute or percentage uncertainty. Okay, and then let me see if I can find the definition of errors. So I got this from the Oxford Exam Success by John Quill. The orange book lah, like I like to tell my student, the orange book. Okay. So anyway, here is error and uncertainty. So you need to know the difference between systematic and random errors. Can ask MCQ, can ask you to write a brief sentence in paper 2. So systematic error here, it can be, let's say this is the true value, and all your measured value is here. So this is precise. Because what? Precision. How many times I can repeat the reading and get the same reading? Okay. But it's inaccurate lah. Maybe there's a calibration error. Maybe you measure things wrongly, or you sub wrongly into some wrong equation. Nobody knows what's happening. So systematic error is because we are displaced from one way or the other from the true value. So causes for systematic error can be because error in instrument. But in paper 3, you don't write error in instrument. If you do your paper 3 and there's a problem in the experiment, raise your hand. We will come and help and double check. Okay, incorrectly calibrated scales, you don't have to do any calibration, but so don't write any of this in your paper 3. Change in environmental condition. Maybe you do experiment halfway aircon spoil, very unlikely to happen. Use a micrometer with 0 error. All this got problem, no? So we reduce systematic error by checking for 0 errors. You do average, cannot. So if I want to define systematic error, the recording, I would use a sentence where I say the measurement is always greater or less than true value by a certain amount. Okay, greater or less than true value by a fixed amount. Okay, the keyword is always greater or less than true value. Okay, random is limitation of the experimenter. For example, judging start and stop of the oscillation. Maybe you sian already. You go and measure 20 oscillation 20 times. Walao, that is 400 oscillation leh. You see also you want to fall asleep already. Okay, so random error lor. Okay, so it can be reduced by taking average like this. Okay, so if you want more about this uncertainty, you can go and look at the pocket guide. Pretty sure there are some in the ET Physics channel. Miss Ellie got provide more explanation regarding this. But that's all about paper 2. Okay, no more now. All right, so I'm going to stop the recording. So it's chapter 1 and chapter 2. I generally think that you can expect about, for both chapters, probably in its entirety, for both, this is chapter 1, you get about 6 marks the most. And then for chapter 2, maybe you will get 2 to 3 P1 question. And if you get a whole question, it can be up to 7 P2. So that means total list is 6. The highest can be 10. But of course, do bear in mind that we do test these things in other chapters a lot as well. Okay, so that's it for the review for chapter 1 and 2. Very foundational basics for AS. You don't know, then very hard to survive. I'll see you in the next video.